Hello friends, welcome to my YouTube channel. Today we will discuss a topic from mathematics. Today onwards we will start the mathematics first module. Okay, engineering mathematics basically. First module, which is our Laplace transformation. Okay, we will cover the Laplace transformation in 5 to 6 videos. Okay, and this is the introductory video, and we'll see the basic formulas and basic things in Laplace transform, and in this video we'll enter to the topic, and later on we'll solve some questions, complicated questions, and enjoy. Okay, let's get started. Okay, before going to the topic, let's collect some basic knowledge. Okay. So here one term, what is transform? Okay, we have to know first what is transform or what is transformation. This is very important. Before going to the topic, we have to know first what is transformation. So transformation means making a marked change, making a distinguishable change in the form, nature, or appearance. Okay. Basically, transform is taking one thing and giving another in return. Where transform means giving one type of input and taking other input, other type of output. Okay, this is basically the transformation. Okay, we have to transform from one thing to another thing, one type of thing to another type of thing. This is basically transformation. Okay, mathematically transform means taking one function or taking one type of variable and make it another function or another type of variable. Okay, this is basically the transform. The derivatives are the transformations, the integrals are the transformations. Okay, not always, because if if okay, we have a function of x and another, in the result we also have the function of x, then nothing has transformed. But if we have one function of n x and by doing some process and we get another function in y, then this is a transformation. Okay, transformation from x to y, transformation from a function of f to function of g. Okay, this is transformation. So what is Laplace transformation? Then coming to the topic, what is Laplace? Laplace transforms. Okay, what is Laplace transforms? Actually, this is a transformation given by the mathematician Laplace. Okay, and the transformation work in this process. L of f of t. It means we call it. We have a function f of t, or a function f in t. Variable is t and function is f. If we will calculate the Laplace transform, if we will transform this function, the Laplace transform of this function will be equal to 0 integration 0 to infinite e to the power minus st f of t dt. Okay, this is the Laplace transformation. This is very important and the basic formula of this chapter. Basic thing, the most basic, most minute, the brick of the house. Okay, Laplace transformation of f of t. All other formulas, all other things are derived from this. Okay, Laplace transform of f of t is equal to 0 integration 0 to infinity e to the power minus st f of t dt. Okay, by putting the limits, by integrating this function, integrating this, okay, and putting the limits of t, okay, 0 and infinity, we will get a function of s. Okay, we'll get a function of s only, because by integrating this, s is a variable. Okay, by integrating this we will get a function as s and t, and putting in the limits of values of t first in infinity and then 0, then it will be a function f of s, function of s, which is known as Laplace transform of f of t. Very simple. Okay, the main application of Laplace transform is solving complicated differential equation by transforming the variables. Okay, we'll see in the next videos that how we use the Laplace transformation. Okay, so coming to the topic, let's get some values of the some standard values of f of t. Okay, and find out the Laplace transformation of for some standard values. Okay, I'll just detect the formulas, give you the formulas. The proof is very easy. Okay, here first some standard value. Okay, Laplace transformation. Okay, Laplace transformation for some standard values. You can prove this formula by very easy method. You have to just put the function and place of this. Okay, put the function in place of this, and the variable which is used in this function here, and the integration will give you the f of s, the Laplace transform. Okay, so first, okay, first is Laplace transformation of 1. What is the Laplace transform of 1? Okay, this will be 0 to infinity. How it is done, I will see. So how to it will be minus s t. Okay, because our variable is t. Okay, and 1 f of t dt. Okay, here f of t dt. So our f of t is 1 into 1 into dt. By solving this integration and putting the limit of t from 0 and infinity, it will be 1 by s. Okay, so Laplace transform of 1 is 1 by s. Second, Laplace transformation of t, the variable itself. So this will be 0 to infinite e to the power minus st into t dt. This is very easy. Okay, this is very easy integrations. Or hope you all have done the definite integration in +2. So I'm just skipping this. Okay, skipping this integrations. Okay, it will be by putting the values, it will be 1 by s square. Okay, third, Laplace transform of t to the power n. Okay, where n belongs to natural numbers. Okay, n belongs to natural number. This is equal to n factorial by s to the power n plus 1. It means Laplace transform of t to t square, tq anything is equal to 2 factorial by s to the power 2 plus 1. Okay, next is 2 by s cube. L of t square is equal to 2 by s cube. This is my formula. And the fourth is here I want to give one formula here of t to n. Okay, this is one recurrence relation n by s. Laplace transform of t to n equal to n by s of Laplace transform of t to the power n minus 1. Okay, this is very important. We'll prove this. Okay, let's prove this relation. Here f of t is t to the power n. Okay, so Laplace transformation of t to the power n will be by formula 0 to infinity. Okay, e to the power minus st into t to the power n into dt. Okay, simple. By using by parts. Okay, this is our first variable, this is our second variable. By using by parts, integration of this into this function. Here integration will be done with respect to the t. Okay, minus 1 by s e to the power minus st. That's integration, first function integration, and the second function. Okay, plus integration of this function into, no, it is minus. Okay, yeah, this will be minus integration of this function into derivative of this function 0 to infinity. Okay, 1 by minus 1 by s e to the power minus st, integration of this into derivative of this second function n to the power t to the n minus 1 dt. Okay, this is looking similar. Oh, this is looking similar to something. Let's see. Okay, putting the limit. Okay, putting the limit here 0 to infinity. This is minus 1 by s e to the power minus infinity, which is 0. Okay, e to the minus infinity is 0 minus here n plus of t, you put 0 to n at 0, so it is basically 0, and in minus and minus will give you plus. Okay, we're taking the constant outside, n by s 0 to infinity. Okay, a to the power minus st into t to the power n minus 1 dt. Okay, so this is 0 plus n by s plus, okay, Laplace transform, and this is Laplace transform of t to the power n minus 1, where you can see here this is not the multiplication. Okay, this is Laplace transformation of t to the n minus 1, so t to the power n minus 1. Okay, so Laplace transform of t to n is Laplace n by s into Laplace transformation of t to n minus 1. This is multiplication. Okay, good. Now taking some other formulas also. If here in the previous formula it was n was in set of natural numbers, but for all real numbers, okay, Laplace transform of t to the power a. Okay, where a belongs to the all real numbers, then it will be, we'll use some gamma function here. Okay, there is a function we will discuss later on in the next chapter. Okay, this is gamma function. I'll just give an introduction to gamma function. This is written like this. This is gamma function. Okay, Laplace transform of t to a, where a belongs to real number, is gamma function of a to the gamma function of a plus 1 divided by h to the power a plus 1. Okay, Laplace transformation of t to a, where a belongs to real number, is equal to gamma function of a plus 1 by s to the power a plus 1. Okay, what is gamma function? Gamma function is, it is also similar to this, 0 to infinity e to the power minus x, okay, into x to the power a minus, I'm using another variable px. So gamma is okay. Gamma of a is 0 to infinity, integration 0 to infinity e to the power minus x into x to the power a minus 1 dx. So gamma function of a plus 1 will be 0 to infinity, okay, e to the power minus x, e to the minus x into x to the power a, okay, a plus 1 minus 1 a into dx by s to the power a plus 1. Okay, this is our Laplace transformation of t to a. Another formula here, another relation is the, for gamma function, another relation is the, okay, gamma of n, any natural number, any real number is equal to n minus 1 into gamma of n minus 1. Okay, this is also a very important formula. You can remember this also, very useful. Okay, let's do some other formulas for exponential function. Laplace transformation of e to the power at. Okay, what is the Laplace transformation of an exponential function? So 0 to infinity, integration 0 to infinity e to the power minus st into e to the power at dt. Okay, e to st minus st into the ft dt. So it will be simplified like this: e to the power at minus st dt. Okay, and the answer will be 1 by s minus a. Okay, by integrating and putting the values we will get, so Laplace transformation of e to the power at, very important formula. This is, we have to remember all these formulas, because by when solving questions in exam you do not need to waste time to find out these formulas. These are very simple and interesting formulas, you just have to remember this. Okay, let's do some other formulas also. Now we'll see the linearity theorem of Laplace transformation. Okay, here Laplace transformation of a ft plus b gt. Ft and gt are different functions and we are two constants, is equal to, okay, a of Laplace transformation of ft, okay, plus b into Laplace transform of gt. How it is applied? A t square plus b e to the power t. Okay, so a into Laplace transformation of t square, okay, plus b into Laplace transformation of e to the power t. Okay, a into a t square, okay, 2 factorial by s to the power 2 plus 1, t to n formula. Okay, t to n equal to n factorial by 2 s to the power n plus 1 plus b into L of e to the power t. Here a is equal to 1, so 1 by s minus 1. So 2a by s to the power 2 plus 1 plus b into s minus b by s minus 1. Okay, this is our Laplace transformation linearity theorem. Okay, let's do some another formulas for hyperbolic functions. Okay, for hyperbolic trigonometric function. Okay, L of cos h a t equal to s by s square minus s square. Okay, and L of Laplace transformation of sin h t is equal to a by square minus s. These formulas are similar and easy to remember. Okay, in the cos this is above is s, and in sine hyperbolic sine above is a. Okay, and let's see some trigonometric formulas. Okay, L of cos omega t is s by s square plus omega square, and L of sin omega t is omega by s square plus omega square. You remember these four formulas, these are very important, and you can make some tricks to remember this function. Like let's see the trick here. If cos is there, above is s. Okay, if cos is there, above is s, and if h is there, below is minus. If h is there, below is minus. Okay, for hyperbolic this will be minus, and for what for cos this above will be s. These two lesson you remember, and for formulas will be remembered. Okay, these are from some basic tools to enter the Laplace transformation. We'll see some more complicated problems in the next videos. Thank you.